Hi, welcome to clickmyproject.com. The title of our project is Knowledge Fusion for Probabilistic Generative Classifier with Data Mining Applications in the domain Data Mining. Let's see the brief explanation about our project. A classification. A classification is a task begin with a data set in which class, assign or known. That is, we are classifying the data based on the data sets. That is, the classification may be in n number of parts. With the n number of parts, we are going to combine the data. That is the main task in our project. Now we introduce a new fission classifier at the level of parameters of classification rule. This technique is based on the use of probabilistic generative classifier using multinomial distribution for categorical input dimension and multivariate normal distribution of the continuous one. That is, the classification is a probabilistic generative classifier. That is, we are classifying the data based on the probability, and based on that probability we have a parametric value. With the parametric value we are going to fission our data. The fission is nothing but we are going to merge our classification in a probabilistic manner. The main advantage of the fission approach is a hyper distribution are retained through the fusion process. In our existing method we use degree of belief distribution to distribute our data sets. The data sets were get distributed, but the knowledge of the data sets were be low, and the high in our existing we use a Bayes algorithm to distribute our data. We found the higher error rate and the data losses may occur. In our proposed we have several classification rule. The classification is done based on the rule. That is, first the classification is used in the ensemble, that is in a group of manner, and which the number of realization exists. That is, with the number of real data exists, we are classifying the first data, and in the second rule of our classification is done with the probabilistic classifier, offered with the possible combined classifier at the level of component of mixture model. In our third part, that is our third rule, we are going to fuse both two data classifiers. That is both classifications 1 and the classification 2. Based on the probability, we are going to classify our data. The main approach, we are classifying the problem and we assume the probabilistic generative classifier are used to solve this. Probabilistic classifier provide outputs that are interpreted to one conditional probability. That is, we are going to classify data based on the input and the output of the data. We have several that is done with 5 folds of probabilistic manner, such as if we consider the classification once based on the probability, that is, if we consider the probability 1, 5, we have the probability manner as 1, 1, 1, 2, 1, 3, and 1, 4, and 5. Based on the probability, we are going to classify the data, and at last we are going to fuse our data. The main advantage in our proposed manner is that the class positional probability are very useful to weigh a single decision, and a rejection criterion could easily be defined. In a dynamic environment, it is possible to detect novel situations. Let's see the flowchart of our project. This is our flowchart diagram. On the first stage, we are going to extract our data sets. The data set may contain more than 1,000 and values of data, and at the next level, we are going to classify our data. The classification is done based on our rule. That is, we are going to classify data for both classification 1 and classification 2, and with the classifications, we are going to classify the probability we are going to do the 5 folds of probability classification, that is based on the positional values and the parametric value. We are going to classify our data in a 5-fold, and we are going to further distinguish a positional classification. The positional classification is nothing but we are going to position the data. That is, we are going to parameterize the values of the classified data, and we are going to find the similar parameters. With the help of the similar parameters, we are going to fuse both the classification 1 and the classification 2. That is, based on the join and the union operation, we are going to classify these two data, and at last we are finding the fission result. This is about our flowchart diagram. Let's see the demo of our project. This is our home page. When I click on this home button, I am entering into my first level of my project. That is, here we have a data set extraction process. I am just selecting my data set. My data set consists of large number of data, and I am going to extract my data sets. let me see what all the data we have contained in this data set extraction. And when I click on this view data, now my data set has been extracted and the data has been viewed. I have an extraction as age, work class, final weight, education number, and the marital status. And when I click on this proceed button, now I am going to the next step, that is the generating classification rule. This is actually our first module. We are going to generate a classification based on the rule, that is we learned already the classification 1 and the classification 2 rule. At last we are going to fuse those two rules. And the rule 1, here I found I have classified the data, that is age, work class, final weight, education, and marital status where we get classified. When I click on this click here button, my data were get stored. And when I click on this rule 2 button, my next classification rule of data were get extracted, that is age, work class, final weight, and the education number instead of education will be get located as the classification tool. And now I'm just clicking here to get on my information. And when I close with the positioner value, this is actually our positioner value. The positioner value is nothing but we have similar sets of data in comparing with those data sets. Then just I'm clicking here to save my data. And when I going into the next process, then my next process will be in the form of knowledge fusion and classification. Now I just classify both the data sets into two parts, that is the classification 1 and the classification 2. And when I click on this classify 1 button, here I have found that the classification 1 data sets. And when I click on the similar data will be get provided here. Here I will be finding the education and not the education number. And here the second level of classification, I have found the education number and not the education. And when I click on this include button, these two sets of data where be gets loaded into our data sets. And when I click on this dimension button, at the first level of dimension, here we have dissimilar data as the education, and same as in dimension 2, here I found the data sets as education number. I just choosing any of the data to fuse our algorithm. That is, now I'm clicking on this fusion button. Here I have found this is actually how the fusion will be formed with the help of classifier A and classifier B. I'm combining both two data. Here I have found the classification A with I have found it, and when I click on this button, here I have found it. And my process has been completed. And when I click on this dimension view button, here I have found the dimension of categorization 1 and the categorization 2, that is the classification 1 found with the dimension, and the classification 2 we found one dimension. And when I click on this next button, this is our next module, that is probabilistic generative classifiers. Here actually we have founded the help of training algorithms. We have founded the dimensions in a different part. We are going to just use those dimensions. Here I'm just clicking on this view dimension, the dimensional view for the classification 1, classification 2, and the fusion classification were get found. And it will be implemented only with the help of convergence matrix. The convergence matrix will be found with the help of this form, that is a dimension 1 into dimension 2, that is a formation of convergence matrix. And when I found the CMM parameters will be found with the help of vector values and the vector value 1 and the vector value 2. The vector value will be designed with the help of this formula. And at last we are founding a hyper distribution. And when I click on this next button, this is our next module, that is a probabilistic classification 1. The classification will be done with the help of in a probability manner. I'm just clicking on this button. Here I found values will be get included. Actually, how the classifications will be done will be in the form of input and the output. The input values will be matched with the output value, that is the probability of final weight and the age will be get designed here. And the same thing, the probability of final weight and the marital status will also be included. And when I click on this next button, the education and the age will be get designed, and the same thing, marital status will also be get designed. Now the probability of 4 folds will be get founded over here. And when I click on this classify 2, the same process, the same thing will be for classification 1 and the classification 2 also will be designed. Here I am going to found the data will be in a 4-fold, that is the final weight will be also in the age, also in the marital status. Now I founded with the final weight with an age. This is actually our work class will be in a positioner value, and the same thing will be found for a marital status. The classification 2 will be found. And when I go with an education number with a probability, I'm founding with the age. here I have found and values. The word class will be in the form of positioner and the probabilistic values. And now I am going with the marital status. The same results will be found with the education number, probability of an education number and the marital status. Now I just clicking on my next button. This is actually my next module, that's the fission technique for classification 1. Now I am going to fission my classifications rules, that is based on our fission techniques and our training algorithm. We are going to find the positional value at the first, and we are finding a likelihood and a likelihood, that is we are finding the two values at the classifications once, one value into priority value, that is a classification 2 with the classification 1 with the second value with the priority, both will be get combined and form into prior value. That is only here I have found. That is first I have founded the positional value, then I have found the likelihood 1 value, then this is actually the likelihood 2 values. That is here when we found here the final weight and the age will be get found, and the work class the positional value will be found. And when I go with the likelihood 2, here I have found the work class, final weight, age and the marital status. And when I click on this probabilistic button, I have found that the values were get merged and the formation of positioner will be found. That is age, work class, education, marital status and final weight will be get founded here. And when I click on this include button, the values will be get stored in our database. Now my process has been completed, and when I click on this get value button, now I have found the similar likelihood of the values of our data set. And when I click on this next button, here I have found the fission technique for the classification 2. For the classification 2, the same thing, we are going to find the positional value and the likelihood 1 we are finding the final weight and the age alone. And when I click on this likelihood 2, I have founded the value of final weight, age and the marital status as the additional thing. And when I click on this include button, my values will be get stored in our database. And when I click on this probabilistic button, now I have found the education number is also get included in our sets. And when I click on this include button, the data will be get stored. Now I am going to get the value of the likelihood and clicking on this. This is actually our next module, that is the implementation of fission. That is we are classified our data based on our first we have classified our data based on our rule, and the second thing we have classified our data based on our training algorithm, and the third thing is we are going to classify our data based on the 5 folds of probabilistic manner, and based on that 5 folds of classified manner we have found the likelihood and the positional value, and we have implemented our form. And now I am going to fission, that is I am going to combine all those values. Here I just combine all those values and find the value of a multiple manner, and I am going to just include all those values in my data sets. And when I count the value, the real sets of data which is found is 8603. And when I click on this next button, here the fission of discharge distribution will be found. That is when I click on this distribution, the hailing distance, that is based on the data sets values will be found, and the continuous and the hyper distribution is also found, that is also called as Bhattacharya coefficient value. And when I click on this fission with chart, when we go with the fission with chart distribution, here we have found the fused values, that is the first normal distribution, second normal distribution and the fission, that is based on the first classifier, second classifier, and at last we are finding the third classification process will be get loaded here. And now I am just going to check my test error of classification. That is a test error is nothing but we have a data sets of large sets of data. The data set value will be included more than 10,000 or something of data, but at last we are finding only the sum or minimum number of data. What the problem of real data, how the error has been occurred, we are going to distinguish is, for first we are checked with the test error of classification 1, that is a detected error value is 6150, but the actual error found is 4960. The rest of data were be get wasted, and the same thing for classification 2, and it's a whole sets of data. And when we click on this view graph button, the error of classification 1 data sets will be found, and the same thing for classification 2, and the result will be found. This is about our project. Thank you.